Now, today we discuss the deadlock avoidance, and we take an example to clear the safety algorithm. So it is also called the Banker's algorithm. And now we have two matrices. One is actually define the resource assignment, and another is resource still needed by the process. Now we have five processes: A, B, C, D, E, and we have four resources, that is tape drive, plotter, scanners, and the CD-ROMs. Now this matrix shows that how which process uh, assigned how many resources. Like the process A1 assigned 3 tape drive, 1 scanner, 1 CD-ROM. The process B is required assigned one plotter, and process C is assigned one tape drive, one plotter, like that. So this is the process, and this is the already assigned resource for this process. Now this matrix is define how many process is still needed, how many resources is still needed for the process. So still a process A required one tape drive, one plotter. Process B still needed one plotter, one scanner. Process C still needed three tape drive, one plotter. That's it. So this is the way this matrix define the processes and how many resource which is still needed by which process. Now there is a three term. This three term is not every time we use the same notation. Notation may be changed, but there is a three terms will be there. One is a resource available. This is the resource available. Here we mention by E. Not every time it will be mentioned by E. So it can mention by any thing at your examination or in your book. So it is E. E means the resource available. So it is a resource available. So how many resources available for your system? That is how many resources available for your system. And P means the resources assignments. So P means here how many resources assigned right now. That means, let's see, like P, like tape drive, 3 by A, 1 by C, and 1 by D. So 3, 1, 4, and 5. So 5 tape drive is already assigned. So 5 tape drive is already assigned. Now the plotter, see, the plotter is 1 by B, 1 by C, and 1 by D. So 3 plotter is already assigned. So we write here 3 is already assigned. So this is shows that how many is already assigned. So as well, scanner is same, the 1 by A and 1 by C. The CD-ROM, one is assigned by for A and one is assigned for D, again 2. So 5322 resources is already assigned. If you sum up the resources, you can see how many resources is already assigned. So now the A here A here actually define that how many resources available right now. So it can be calculated because maybe it is not given by the examination. So these two, sometime the examination, in the examination these two will be given. So this is not given, that you can calculate it what is your resource available or free resources. So how many resources already available and how many resources assigned, subtract two terms, and that you will get how many resources still available. 6 minus 5 1, 3 minus 3 0, 4 minus 2 2, 2 minus 2 2 0. Sorry, so 1020 is the resource right now available. So how many resources right now available in your system? That is 1020. That is 1 tape drive, no plotter is available, 2 scanner is available, and 0 CD-ROMs is available. So this is given, and there is a so many way the question is given in your examination, not in every time in matrix form. Sometimes they given in the text form, that how many process and how many resources is required, or how many resources is still needed, or how many resources is assigned. So if it is given in matrix form, that will be easy, but you not think that every time it is given in exactly in this way. Anyway, but data is given, that you can capture, you can form your data and calculate your answer. Now the question is, your available resource is 1020, and that this will call this is the called the state, and right now what is the state? That is 1020 resource is available. Now when the 1020 resource is available, at this time we see that your system is the state is called the safe if there is a sequence in which the safety, the needs of the processes, that mean is very clear that your available resource is 1020, and by 1020 in what sequence you assign the process, you assign the resources to the process, in what sequence, that can you say your process your system is not occurred any deadlock. That means you have 1020 resource, okay, and all resources not the same, all resources are different. If you see in my previous class that we already discussed, the in that time the process is same and we using the multiple instance of the process. In that case we can calculate it how many processes, maximum processes required which never occur a deadlock. But in that case the process is different, so it is Banker's algorithm. So in that case the available resource is given, or we calculated the available resource also, and now you can see in what sequence if you give the resource to the process. So what is the sequence, in what sequence you give the resource to the process, that can be, that can never occur a deadlock. So see the process is ABCDE, that as per the given in the matrix, or the other sequence, so which will not never occur a deadlock. So let's see, the resource is 1020 is available. First, if you allow a process to fulfill their requirement, is it possible or not? First we see. Now we have 1020 resources, so can we allow a first? Because a required 1100, one tape driver, one plotter, 0 scanner, 0 CD-ROMs. The available resource is 1 tape drive, 0 plotter, 2 scanners, 0 tape drive. So A required 1 plotter, but the plotter is right now available is 0. Availability of the plotter is 0. So we cannot assign A first, because A required plotter is not right now not available. Now can we start B first? That means can we give the can we fulfill the requirement of B first? Let's see what is the requirement of the B. 112, 0112. So 0112, that means B required, the requirement of the B is 2 CD-ROMs, but nothing is available, no CD-ROM is available right now. So we cannot actually allocate the B also. Now can we start C? So what is the requirement of the C? 3100. So 3 tape drive is required. The requirement of the C is 3 tape drive. Now only 1 tape drive is available. So in that case we cannot start C also. So can we start B first? 0011. That means only scanner is the simple requirement of D is only 1 scanner. So scanner is available. Yes, okay. 2 scanner is available. So in that case the requirement of D is 0010 and the availability is 1020. So 2 scanner is available and D requirement is only 1 scanner, nothing else. So we can allocate D. If we allocate D first, D is finished. And what D released? D released 1 scanner. So what we'll do, we can give the requirement of the D, we can allocate the requirement of the D because it is available. So we can start D first. If we can start D first, the D is finished, nobody disturbed D, and after finished D, D release 1 scanner. So right now what is your availability? 1 tape drive, 1 plotter, 2 scanner, and right now 1 scanner is released by D, so 3 scanner and the 0 CD-ROM. So let's see. Matrix is important. So D is allocated. So sorry, there is one confusion. Sorry, there is one confusion. So if D is finished, because D is already assigned 1101. Okay, so there is a confusion. Not let's clear the confusion. D is already assigned 1 tape drive, 1 plotter, 0 scanner, 0 CD-ROM. Right now D is only needed 1 scanner, and we can fulfill the availability because 2 scanner is available. So we can allocate the 1 scanner to D, and we start the D process first. We finished the D process, and when D process is finished, after finish the process D released all the resources that is holded by the D. So how many resources D holded? 1 plotter, 1 tape drive, 1 plotter, 1 scanner, that is right now fulfilled, and 1 CD-ROM. So 1 if you not consider this one, because 2 scanner is already there, so if you add this one, we should subtract 1 from here, so it is equal, so we cannot consider this one. We consider already 2 scanner here. If 1 scanner is given to the D, so it is 1. Again you add the same thing to here, it is 2. So here 1020 is availability. What is given to D, it is just you not consider here, because you only consider the when after D what will be the resources released by the D, 1101. So 1101 resource will be added to this availability, because this is the available when no process will be finished. Now after D will be finished, D releases 1101. So now we have 1020 availability and D release 1101, so it is 1 2 it is 2121. Now see the matrix. We have 2121 availability. We have 2121 availability. Just wait, I take a page. Right now my resource availability is 2121. Now see the matrix. A required 1100, so that is fulfilled, so that is no problem to allocate A, because A required 1 tape drive, 1 plotter, and 2 tape drive, 1 plotter is available. So we allocated, we will allocate A. After D we can start A. Now the A is finished, so A, after finished A release all the resources which is holded by the A. So again after finished A, we added all the resources which is holded by the A, that is 3011. So it is 2315. Understand, that is 5132. Now D is finished, after that A is finished. Now see, it is 5132. Can we allocate it the requirement of B? Yes, we can allocate it the requirement of the B, because requirement available 5132 after finished of D and A, and requirement of the B is just simple 0112. So everything is available here. So B is, we can allocate B. After finish the B release all the resources which is holded by the B. So just add it, all the resources which is holded by the B, 2325. So right now it is 5232, and now it is B. Okay, let's see. 5232 is available. Can we allocate C? Easily you can allocate C, because the resource is available 5232 and requirement is 3100. So if we allocated C, and after finish the process of C release all the resources, so it is added to your availability of the resources 1110. So it is 2436 634042. Sorry, 6342 is right now available. The only process is left, that is E. So you can allocate it is easily. That is not a problem. So the sequence is D, B, C, E. We have 5 processes, 1, 2, 3, 4, 5. So this is the sequence. If you maintain the sequence, your system will be safe. That means the deadlock will not never deadlock will not be occur. But this is not only one sequence. In that case, the deadlock will not happen. Maybe there is a more than one sequence by which the deadlock will not occur, or maybe there is some sequences there by which the system is not safe, because in that sequence the deadlock may occur. So maybe you have a lot more than one sequences there by which we can say that the deadlock will not be occurred.